Now, with this, all these things, finally we came to this point. And when we have this type of circuit, we should be able to write output equations like this. Okay. Then this is the output equation of this circuit, and this is the output equation of this one. And we need those things, and the reverse of this one also we discussed. For example, when we have this type of equation, okay, this is the equation we are having. Okay, then for this equation, we should be able to draw this circuit. Then both sides we have done. And when you have an equation, you should be able to draw the circuit. And when you have the circuit, you should be able to draw, we should be able to write the equation. Okay, that's what so far we have discussed. I think with all these things today, we can start designing of digital circuits. Okay. Actually, today what we are going to do is we are going to design circuit based on the experience we have gathered the last thing. Okay. Okay, to do this one, actually, that we can do certain things. We can put certain things together, and how we are going to design a circuit means that to do that, we have a very simple mechanism. We have a very simple procedure to be followed. Okay, we can consider about the standard design procedure for designing the circuits, digital circuits. Yeah, we can take a small example here. With that, I think step by step, I can explain all these things to you. Actually, why we are designing a circuit? Why do we need to design a circuit? Because we have to address certain real world problems. We have a problem and we want to address that. Here that I'll take a very small example. Actually, we are going to expand this one later on. Shall we consider this example? Okay. Assume that this is a room. Okay. We have two entrances here. The first entrance is A. The second entrance is B. Sorry that I couldn't. I think now you can. We can start this one. You can hear that this is small. Here we have two doors. It's a small room, and we have two entrances, two doors, assume two doors, and we have fixed two door sensors there. With that, I think you can identify whether door is open or closed. Okay. Then that owner of this room is coming to you and telling that he want to make a security system for this room. Then he will explain his requirement. Maybe that first condition is the first condition he is telling that when door A is open and B is closed, that is one security condition. Okay, second condition according to him, when both doors are open. When both doors are open, that is another security condition according to him. Okay. Then at these two cases, alarm should be sounded. We can have an alarm here. This is an alarm. Then we want to make a circuit to sound the alarm when these two security conditions are coming. Okay. Then we make a circuit and this is the circuit we are going to make. Okay. Then these two wires are coming from the sensors here. We have fixed two sensors. And this circuit will determine whether one of these conditions are true. If one of these conditions are true, we have two conditions and we have to check any of these conditions. When one of these things is true, then we have to turn on the alarm. That is the idea. Okay. Then to do this, I'll explain it step by step how to do this one. The first step of our standard designing procedure. Draw a block diagram. Showing all input output lines, but here it's not you might think that this is not a necessary step here, but this is essential for any kind of circuit. For simple one, that it's not necessary, but for complicated one also, then if you do like this, then you will not do any mistakes. Okay, showing all inputs and outputs. Shall I do this one first? This is the first step. Okay, then we can draw this block diagram. And this is the block diagram of the circuit we are going to make. Okay. And this is input A coming from door A, and this is input B coming from door B. And here we have to produce an output. Shall we put because of this alarm, we say it's L. Okay. This is the block diagram. The second step. Second step, prepare the truth table. For the circuit. The circuit for the problem, for the system, or whatever the thing. And to prepare the truth table, what we have to do, and we have to include columns for these inputs and outputs. And here, in our case, we have 3 columns in our truth table. First column is A, B, and this is the output column L. You know that these are the 2 inputs coming from 2 doors, and the sensor outputs may be 0. 0 may be door is closed. And B also door is closed. Here, still door A is closed, but B is open. Here, A open, B closed, and both are open. Okay. Then we can look at the conditions he has given. First condition, when door is open, A is open and B is closed. Here, A open and B closed. A open and B closed. And both those are open. These are the combinations. These are the conditions. And A open and B closed means A1, B0. A1, B0. A1, B0. Here, L should be 1. Alarm should be sound. The other one, both those are open. Here, A1, B1. Here also, alarm should be sound. But in these 2 cases, alarm should not be turned on. Up to this point, is it okay? What do you think? Up to this point? Yeah, actually what we have done here is we have converted whole problem into a table. Now, a couple of minutes ago, it's in verbal format. Now it's a text. Okay, we have 2 lines explaining the problem. Now we have converted everything into a table. Now the problem is inside the table. The next step is write output Boolean equation for the circuit. That's what we have to do. Now we have converted the problem into a table. Now next step, we have to write output Boolean equation for the circuit. Okay. Then how can we write output equation using this table? That is the next thing, next question we are having. Okay. What are the combination we have to consider to write the output Boolean equation? These 2 combinations, because here at this combination output should be 1, and here also output is 1. Then these 2 combinations we have to consider. Then how can we convert this one into a term? Okay, look at this one. If I write this way, this is A, B bar. This one, AB. What I have done here, I have used AND operation to combine this one and this one together to represent this one. To represent this combination, to represent the second combination, again I have used AND operation to combine these both A and B together, A, B. And using AND operation, I have done it. Then what about this one? If I use O operation to write this one, then this should be A plus B bar. This is A, this is B bar. This one, AB. Now using two operations, now we have written this one in two different ways. What do we need here? We want to take these two. Why? At these two occasions only, we have to turn on our alarm. Okay. To do this, here we have used AND operation to take this term out. And here we have used O operation. Which one is the correct one? Both one should not be correct. But one of these things should be correct. Which one is the correct one? Which operation we can use to consider this one? AND operation or O operation? What do you think? Yes. Dirana is saying that is AND and Sajan is telling operation. Yes, AND O. Okay. Then you have to think about that. We have different answers here. Then we have to think about that which one is the correct. Then you have to revisit what we have discussed previous day. Okay. What is the meaning of AND operation? What is the meaning of O operation? Why do we use AND? When we want to check that both conditions are true at the same time, then you have to use AND. But when you want to check one of these conditions are okay, one of these conditions are true, then you can use O. Now you can take some idea. If you want to check both things together at the same time, it should be AND. If you want to check one of these things, then answer should be O. Now what is matching here? The answer is this. Okay. This is the correct one. And we can't use O. You will realize this one when I write the output equation. For example, assume that for the moment that if you didn't realize that why AND is here. Then to make the output equation, now we have taken AB bar. The second term is AB. Okay. Now we want to write output equation L equals AB bar and AB two terms are there. Then how can we combine these two terms? This is actually one combination. Though A is open and B is closed. This one, both are open. Now we have two different combinations, two different conditions. How can we combine these two conditions together to write combine equation for L? Then this should be O. If you have this combination O, this combination, if you have this condition O, this condition, L should be sounded. Alarm should be sounded. L should be turned on. Is that okay? But here we are checking. One of these things are okay. One of these things are what? One of these things is true. Alarm should be sounded. One of these things. We are not going to check both things. We are not going, because that in reality, both conditions should not be satisfied at the same time. How can we say that though A is open and B is closed, with that condition, at the same time, is it possible to have that both those are open condition? No, they are two different scenarios, two different things. Then we can't combine those things. Then we have to say whether this combination true or this one is true. Then one of these things is true, alarm should be sounded. Okay. Then I think, again, if we look at this one, what we have done so far, this is the problem we have, and we have small room and we want to make a security system here. Then according to the owner, he is having two conditions. Though A is open and B is closed, then alarm should be sounded. Both those are open, alarm should be sounded. He's having two conditions. And we draw a block diagram to show that what type of circuits we are going to make and how many inputs are there and how many outputs are there. Then in the second step, we prepare to table, including all the combinations here. And this is though A is open and B is closed. This is the combination. At that time, L should be 1. Here, both are open. Then at here also, L should be 1. Then our next question was how to convert this one into an equation. Then first thing, that this combination should be converted into a term. Then to do that, we have selected AND operation. Then there, you have to remember that one. All the time you have to use AND here. Okay, then after writing these two terms, then we have to combine these two terms, but it should be a one equation. Then to combine these two things together, we have to use O operation. Okay, some questions were raised. One question, I think, can you explain it again from the selection of O gate? We can't just focus only on the opening and closing of the A door only without taking into account the B door, like connecting a circuit only to A. So I cannot understand that what you are asking, that question, that we can't just focus only the opening and closing of the A door only. Here we don't consider one door only. We are considering two doors. At the same time, we have to consider two doors. But otherwise, that we cannot. One of these our conditions is when door A is open and B is closed. Then we have to check whether that condition is true. We have to check both those. All the time we are checking both those at the same time. That's why we are using AND operation. With AND operation, both things should be satisfied to have a result. Okay, then that's why we use AND operation here. Then here we are not considering, consider only door A. Here we consider A and B both together. This door A is open and B is closed. And this combination is A, B bar. When we take A, B bar, A is open, B is closed. That one is included in the term. Okay, one question is asked, could you please explain how would we decide we take 0 when a door is closed and when 1, the door is open? Actually, it's Prabhavi. Okay, here in usual practice, we take like that. But otherwise, if you have different senses, but in this case, we have to actually at the very beginning, we have to define 1 means open, and 0 mean closed. But assuming that sensor is working like this, when this door sensor is fixed, it produces 1 when door is open. It produces 0 when door is closed. Okay. But if you want that, you can take the other way also. Then your truth table is different. That is one question. The other one, door opening with anyway sound the alarm. Door A is opening will anyway. Yeah, that will be true that when door is opening, when door A is open, for all these cases that alarm should be sounded, but that is coming from that we are arbitrarily selected these two combinations. But if you select different combination, that one is not true at this time. But anyway, that don't think about that the taking one door at a time. But in this case, according to the combinations we have selected, the conditions we have selected, whatever the time door is open, door A is open, alarm should be sounded. But all the time it's not. In different time, the combinations may be different. But here we are going to make this standard designing procedure for all the cases. It's a common standard designing procedure, but if you follow this one like as I explained, and we will not do any mistake. But whatever the door is open or closed here, when you want to convert your truth table into terms, this is the way you have to follow. But in this case, we have ones here, but in different case, the one may be here. Then the output, this one may be A bar, B bar. If you take like this. Okay, you will realize that when we take other questions also. Can please explain again that how we get AND operation for the previously asked question, green highlighted one. Sajjani, that here, why we are using AND here is that otherwise that there is no other way to use to check these both things together. Okay. In this case, why we use AND operation? With this AND operation, we want to have both conditions satisfied. Both conditions are true, then only this AND gives output. That's why we say that here, when you come to this one, that you can realize very easily this one. But consider this equation. Then why here we use operation? Because this combination, this condition and this condition, both conditions will not be satisfied at the same time. There are two different conditions. There are two different occasions. If you write this equation like this, okay, if you write this equation, can we write this equation like this? What is the meaning of this one? Then this should be true, this should be true, then only L will be 1. But this will never happen. Why? When door is open and B is closed, both are open. How these two combinations are coming true at the same time? It's not possible. Because of that, we can't do this. Then here, that's why we use operation. If this is true, L should be 1. If this is true, L should be 1. That's why O is here. But in this case, we have to check very correctly. Door is A is open, B is closed. To do that, we have to use AND. Okay, then fourth step. Now you have equation. Now in this third stage, what we have done? In the second stage, we have converted the entire problem into a table. The Third stage, we have converted entire problem into an equation. Now you know what to do next. Draw the circuit. Using basic logic gates. We have practiced this one. When you have an equation, you know how to draw circuit. Okay. Then we can draw the circuit. Now this is A, this is B. We need B bar. First term, we want to make this A, B bar. Here we have A, B bar. And second term, we want to make that is AB. This one AB. And after that, we can combine these two terms together using operation. And finally, we have L. Okay. Now, these are the 4 very simple steps you have to follow to address this problem. But we will modify the standard designing procedure later on. But for the moment, you have 4 steps to be followed to design a circuit. Is it okay? Anything? Any question? But if you have any question, now it's time to ask, so that from this moment onwards, we are going to follow this one.
Excuse me, sir.
Yes.
Sir, what is the objective of drawing the block diagram?
Putha, that here, as I mentioned very beginning of this one, is the objective of drawing this block diagram is it's obvious that you don't need that this one to another. But anyway, that here when you draw this one, in this case, you have only 2 inputs. And 1 single output. But when you have a complicated circuit, then you should know that how many inputs are there and how many outputs are there. Okay, that is the only purpose. It's a very simple thing here. Otherwise, this is not a big step here. As a practice, normally that before we design a circuit, we draw this type of block diagram showing that all the inputs and output connections. Otherwise, that there is no purpose.
Thank you, sir.
Okay, if you are okay with this, then I'll give you a little bit improved version of this one, a different question. Okay, this one. Here, in this case, we have 3 sensors, 3 door sensors, A, B, C, and emergency bell E. And you have 4 combinations, 4 conditions here with 3 sensors, you have 8 combinations, 8 different combinations starting from 0, 0, 0 to 1, 1, 1 like that. But here you have 4 different conditions to turn your alarm on. Then draw a block diagram and make a truth table and write output Boolean equation and draw the circuit. This is the standard designing proceeding. Shall we try? Okay. You can take some time and try to do this one your own. Okay, these are the, I think you have done it, maybe. These are the 4 combinations we have to consider. Yes, Sarusha, that's correct. Well done it. Okay, we'll go step by step. First step is drawing the block diagram. It's an easy step. We have 3 sensors here. Then, so we have to have 3 inputs there. This is first one. Third, an emergency bell E. Second step, we have to prepare a truth table. In this truth table, how many input columns? We have 3 input columns, A, B, C, and 1 output column, that is E, alarm. Okay. Then here, I think you have 8 different combinations, and how do we know? Because of that, we have 3 inputs, then 2 to the power 3, 8 combinations are there. These are the input combinations, the 2 to the power 3. Then starting from 0, 0, 0. I'm writing this one in ascending order of binary values, but then if you write this way, you will not miss any combination. Then if it is not possible to remember these things, that remember, write these combinations are one easy way to you have to do. Then you know that first combination you can put it 0, 0, 0, and you know that 8 combinations are there. Then put in 0, 0, 0 here. The first column you can see that this one is 0, 1, 0, 1, 0, 1, 0, 1 for 8 times. Second column, 2 zeros, 2 ones, 2 zeros, 2 ones. Third column, 4 zeros, 4 ones. If you have fourth one, 8 zeros, 8 ones. Like that, it's a very simple pattern is there that you can follow the pattern, that if you are not having experience to write this way using the ascending order. But anyway, that we can consider the combinations. The first combination is A on, B off, C on. Here, the meaning is A on means A is 1, is B0, C1. Here, A0, B1, C1. Here, A0, B1, and C0. This is A0, B0, C0. Okay, let me, to get the number of combinations, then here you know that how many variables are here? 3 variables. Okay, it means 3 inputs, we say. It's 3 inputs. Now, this is 3 inputs. Then 2 to the power 3, 8. Then 8 different combinations. It's okay. Then if you have 4, then 2 to the power 4, 16 different combinations. Okay, then first one, 101, 101. Here at 101, 101. Here, this one, E should be 1. The second combination, first one is 101, then 011, 011, 011. This should be 1. The third combination, 010, 010, 010. The final combination is 000. And for all other combinations, E should be 0. Okay. So we have to write output terms for this one. What is this? This is A bar, B bar, C bar. Can I? This one. Here, this combination, A bar is B. This is C bar. First combination, this is A bar, B bar, C bar. This is A bar, B, C. This combination, this is A bar, B, C. Okay. Last one we have to consider here. This is A, B bar, C. A, B bar, C. Okay, then we can write output equation. First one is A bar, B bar, C bar plus A bar, B, C bar plus A bar, B, C and A, B bar, C. Then we have to draw a circuit for this one. Okay. Then this is A, B, C. We need A bar, B bar, C bar also. First, I make this A bar. This B bar and C bar. Shall we make first term this one? B bar. Here, B, C. We have C bar here. And B is here. And we need A bar also. This is A bar, B, C. Okay. Then next one, A bar BC. This is C. This is B. A bar BC. A B bar C. We have to make a B bar C here. B bar and A. Now we have to combine all these things together. And take 4 input OR gate here. This is C. Is it okay? Okay, several questions came. So should we use, can you explain how to get number of combinations? What is the meaning of number of combinations? Are the second and third conditions correct? Second and third conditions are correct, means second and third. This one, second A0, B1, C1. Yes, second is correct. This is A0, B1, C0. Yeah, these two are correct. Okay. Then first combination where all three are 0, we can write ABC bar, right? No. It Hasini completely different this one. But we are asking, the Hasini is asking a question like this. Now she is asking that without writing this way, without for the first combination, without writing this one, she is asking, is it possible to write this way? No, this is completely wrong. These two are not equal. Okay, how can we check if you have this type of problem? Then you can use a truth table here. Okay, and for the moment, for the simplicity, I'll take this one. If you want to check this is correct or not, how can we do this one? You can prepare truth table like this. Okay, this is 0, 0, 0, 1, 1, 0, 1, 1. Then this is A bar and B bar. This is 1, 1, 0, 0. This is 1, 0, 1, 0. Then we can make this one. This is our left-hand side. And we can make this equation. This is left-hand side one. And this is your right-hand side. This is A B bar. This one A bar B bar separately. Here, what is A bar B bar? This one A bar B bar. This column. This is 1, 0, 0, 0. This is AB bar. AB bar is NAND operation. In NAND operation, other than this combination, all others are true. Now we have to check whether these columns are equal or not. This is A bar B bar column, and we have to compare it with A B bar column. You can see two different results. Then because of that, this is not, you have to remember this at any time. This is wrong. Okay, some other questions also there. Should we use bumps when wires are going over each other, or it is not necessary? Okay, when you draw circuit, but it's asking a very good question. And Sastrika, and this question, he or she, I can't. And then that if you want to when you have a connection like this, but here these two lines are not connected. But this when I put this dot here, it's connected. But we have two different conventions here. This one, in one way, this is not connected. And this one connected. That is one way of doing it. To have a connection, you have to put dot here. Then it's not connected. The other way, if it is not connected, you have to jump over the wire. Sorry. Like this. But here, in that connection, when we draw something like this, it's connected. But these are two different conventions. But you have to use one of these, not both. Because in this case, you have simply a cross like this. The meaning is it's connected. But here, if you have something like this, it's not connected. If you have a connection, you have to purposely put a dot there to indicate a connection. That's why all time I have put dot here. But I didn't use this jump over the wire one. But if you want that, you can use that one also. But one of these things, not both things at the same time. This is the method one. And this is method two. Method two is actually the old method. Method one, this is the new method. But don't use both methods. You can use one of these methods. Okay, what else? What are the other questions you are having? I think now you have realized that how we can design a circuit. Understanding the practical problem, then you have to think about how many combinations are there. But I think in these two cases, the combinations are straightforward. The conditions, these ones are straightforward. But all the time, in reality, you will not receive combinations like this. The conditions you have to extract from the problem. When you look at the next question, you will realize it. Shall we try next question? This one. Okay, there is an electrical control system. It's having 3 positional sensors. Okay, you can read it first. What is the meaning of this one? There is a control system. And this control system, you have 3 positional sensors. Okay. And we have 3 positional sensors here. We don't know this, what type of sensors we have fixed there, but the purpose of these sensors is that they can detect the positions. Whatever the position they can detect, after detecting that one, they can produce one. We don't care what type of sensors, those things, and the operational principle and how they are producing these ones or not like that, and how they are going to detect these positions. We don't care about this. That is a different technology and different subject. Anyway, the sensors are there. Okay. Then those sensors will produce logic 1 when the position is detected. Now we have to design a circuit in order to produce an output L. Then we have to produce output L when we have identified 2 positions. Because we have 3 sensors, and any of these 2 sensors have identified positions, we have to show it. We have to produce one. Then the condition is little bit extended, 2 or more. Okay. Then when 2 or more positions are detected, then we can turn on this L1. Okay. Then as usual way, you can draw a block diagram. Block diagram is already here now. Then you can prepare truth table. With the truth table, you can put the conditions. Now conditions are not straightforward here. It's hidden inside the problem. Now you have to extract it. The conditions here are only one condition. Then two or more positions are detected. Then we have to turn this L on. Or maybe L should be 1. When you detected the correct position, L should be 1. Okay. Shall we try this one? I think it might not be a problem, but anyway, we try it. Second question, and the usual block diagram is there. Then we can prepare the truth table. A, B, C. Okay. And some of you have done already this one. Then we have to turn output on when two or more positions. Here one position, then it should be 0. Here also one position. Here two positions detected. Only one. Here two, one, two or more. Okay. Then we can convert this one into terms. This is A bar BC. This is A B bar C. Okay, sorry, we have started wrong place. Fourth one ABC. Then we can write output equation. L equals okay. Then we have to draw the circuit. ABC, we want to make this A bar. Okay. Can make this one. This is C bar. B and we need A bar. I'm drawing this one using multiple colors, but then you can understand easily. But otherwise, that in your case for the examination and other time that it is not necessary to draw using multiple colors. Okay. See. B bar. Anything, any question? I think now you can understand all these things. But if you are okay with this one, we can try the next question. That question is little bit tricky question. This one. We have three different sensors: flow rate, pressure, and temperature. You can read and understand it. And two different dangerous conditions are there. Then when one of these dangerous conditions is occurred, then we have to turn on emergency bell. Okay, shall we try this one? Okay, we have three sensors there. Then, and also two dangerous conditions. One condition is when flow rate and pressure are low. That is one condition. At that time, our alarm should be sounded. The second condition is pressure and temperature are high. During that time also, we have to turn on our emergency bell. We have to show that those conditions are dangerous. Then when you prepare the truth table, you will understand and why these conditions are carefully looked in. Okay. Hit that one. Then try your own. Okay, the previous question, and that is the answer for the previous question. We tried this one, I think. Some of these things. And we are starting from here. This is the truth table, and this is the final equation, and these are the circuits we have drawn. Okay, we can. We can prepare the truth table in usual way. Then this time we have 3 different type of sensors, and alarm A, okay. The first condition is flow rate and pressure are low. Flow rate and pressure are low. That is the first dangerous condition. Flow rate and pressure are low. F0, P0. Here, A should be 1. And you can see that there is another combination having F0, P0. And here we have to consider 2 combinations. The other one, pressure and temperature are high, P1, T1. Here you can see P1, T1. And not only here also you can see P1, P1, T1. In other combinations, we put 0. Then we can convert this one into term. This is F bar, P bar, T bar. This is F bar, P bar, T. This one is F bar, P, T. This is FPT. Okay. Then final equation, A equals FPT P bar, T bar, P bar, P. I think you can draw the circuit now. It is not a difficult one. You can, as usual, we can make F bar, P bar, T bars and make these 4 different terms using 3 input and gates. Then after that, we can finally connect all 4 outputs coming from 3 input and gates using 4 input OR gate. Is it okay? Anything? Any question?
Excuse me, sir.
Yes.
So is it necessary to write four expressions in the Boolean expression? Can't we write it from true, sir? That means F dash P only because of T doesn't determine. That means if T was 0 or 1, it could give a result. That because of that, can't we just simply write using only F and P?
Yes, actually that whatever the thing that you are telling is correct, but for the moment we can stick to our designing procedure, but later on in later stage that you will realize that in your case that I can say yes, then all others can remove that one also. But in this case, that it is not necessary to consider the two terms, that you can take only F bar, P bar only. But here in this may be the first special case. But in generally, you should know how to write, how to solve this type of problem. In general way, if you are following the general guidelines, general procedure, designing procedure, and this is the way we are receiving this equation, then you can draw this circuit. There is no harm with this one. This is the actual 100% correct method to implement this one. But whatever the method you are proposing also is also correct. Okay. Then other students might think, they might wonder that how these two methods are possible for this. Actually, that there are many ways to solve this one. But we will come to that one later. For the moment, I am not going to discuss everything here, because otherwise the students that coming from the very beginning, they might not easy to understand this one. Because of that, I think I appreciate that your comment, but here, shall we wait maybe a couple of, I think next day we can discuss those things and how to do that way. But for the moment, we will follow the standard designing procedure. With that standard designing procedure, this is the equation we are receiving. And then you can draw the circuit for all these four terms. Is it okay?
Yes, sir. Thank you, sir. Sir, accordingly, so we should write for, that means we should include four, that means four expressions in the given algebraic, the Boolean expression, including all four having one as output, right?
Yes, yes, yes.
Okay, thank you, sir. Thank you, sir.
But actually, whatever the way you asked that, we will come to the later on that the equation that you have mentioned. But to come to that one also, first we have to write this equation. You will realize those things, I think, next day. Can you please explain the conditions in the question again? This one, conditions are, first dangerous condition will occur when flow rate and pressure are low. Okay. Then flow rate is 0 and pressure is 0. Then that is the first dangerous condition. The second dangerous condition, pressure high and temperature high. This is the second dangerous condition. Okay. Then when you have this first one, I think you can see here, this one and this one, F0, P0, F0, P0. Because of that, we have to consider these two things. These two combinations we have to consider. Okay. In the second case, this one, again we have two different combinations. This is the whole combination. The previous one also, we have whole combination. Okay, in this case, F0, P0. Here, F0, P0, we have two combinations. This one, P1, T1. P1, for P1, T1 also, we have two combinations. Because of that, we have to consider all the combinations. Okay, I think you have come to the certain stage. Now you can look and understand some kind of problems coming in the real world. And for the specific cases that you should be able to understand the problem, then you should be able to determine number of inputs of your circuit and number of outputs of your circuit. That so far we haven't considered the multiple output circuit, but next week we will consider that one also. In this case, you have only multiple inputs but single output. Okay. But for these cases, that you can draw the block diagram showing all the inputs and output lines, and after that you can prepare the truth table. And for all cases that we have prepared only 3 variable truth tables, but later on you should be able to and you will have a chance to prepare 4 variables with tables also. And it doesn't matter 2 variables, 3 variables, or 4 variables like that. But for the number of inputs that you need input columns, and according to the number of outputs, you need number of output columns. Then after that, you have to mark the conditions on the table, that you have to extract the conditions from the question. Then after that, you can mark all these things on the table. The next step is converting those ones into terms. Then you know how to convert those ones into terms. Then after having those terms separately, you know how to write Boolean output equation combining all these separate terms together. Okay. Then according to that Boolean output equation, you know how to draw the circuit using Boolean gates, the basic logic gates. And so far, that is the summary. And at the end of these 2 days, and if you know all these things, and if you are comfortable with all these steps, that's what we are expecting. Okay, I think it may be a couple of minutes past the time. I think you may have another class also, I don't know. But without starting a new question, we can conclude the class today. I think hopefully we can meet next week, next Saturday morning. Until that, thank you very much for your participation and the patience. And be safe and take care of yourself. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.